In this lesson, the focus here is pointers and references. And this is really where things start to get interesting with C++. We have a lot of control over managing memory, so when does it get allocated or deallocate that memory that we have assigned. We can reference memory addresses directly using pointers, and this means we can copy the address of a variable instead of creating a copy of the variable itself, which is far more expensive. So lots of benefits to working with pointers directly. For the most part, in most C++ programs, you'll be using pointers and references, and especially if you write high-performance programs such as operating systems, or if you work with embedded devices that you have in cars, for example, and so on, that have a limited amount of memory, so you have to manage that and write a program that makes use of that effectively. Also, if you work with resource-hungry programs, so games, for example, if you build a game, then the benefits of pointers are quite dramatic because, again, you're not passing around data all that much. All you're passing around is references to memory addresses. So the topic of pointers and memory management in C++ can be intimidating to beginners. And this is often why other programming languages are recommended to beginners. But I would argue if you study C++ first, those other programming languages will be easier to learn. It's a long process, right? You have a lot more to learn. But it's very logical, as you'll see. You just kind of have to get used to the operators, and hopefully with a proper lesson on it, a step-by-step basic introduction to it, it won't be all that confusing anymore. You'll see it's not that difficult. Typically when people write programs these days, or especially game development in something like Unity, they want quick iteration times. With C++, you kind of have to take a step back. You plan things out a bit, so it's a bit of a slower approach. So we can actually get the location in memory where our variable is stored, and we can do that with the address of operator. Now the address of operator using that ampersand symbol is a unary operator that is going to return the memory address of its operand, and this is important because later on we want to save this memory address in a special type of variable called a pointer. Here's a quick example. In demo variable, set that to 12, and then I can do console output, use the address of operator to print out where that variable is stored in memory. Okay, so before moving on to the next section, I want to talk about this conversion table. Now I'll provide a link to this. You don't have to worry about all of these different tables. All we are looking for here is this first section or this first table. You'll see we have the decimal column right here, and that will simply extend in this next table and in the next one and so on. So I talked about bits previously and the difference between bits and bytes. You have 8 bits in 1 byte. Now binary is basically that representation of zeros and ones, and this is basically what the computer understands, so zeros and ones. You also have octal here, so you can see that goes from 0 to 7 here, and then it goes 1, almost like when we do 10 in decimal, 10, 11 and so on. It adds the 1 in front, so it starts at 1, 0, 1, 1, 1, 2 and so on until it reaches 7 again. Then it'll do 2, 2, 0, 2, 1 and so forth. Now in binary, we also start with 0, 0, 0, 1 and then 1, 0, 1, 1 and so on. We actually have a bunch of unnecessary zeros here, but that's probably just to keep it consistent. As you can see, this table kind of keeps going, right? Now in the next section we'll talk about memory addresses, and those are in hexadecimal representation, so the number may look a bit weird because you may have a F in there or a D and so on. So hexadecimal starts at 0, then goes to 9, just like decimal, but it doesn't then start over. So here you can see 0 to 9, and then we add a 1, and then we start at 0 again, 0, and it will continue down till we get to 9, and then we'll add a 2 again, right? And then we'll start at 1 again on the right and so on. The hexadecimal goes to 9, and then we start with an A and we end with an F. So 15 in decimal is F in hexadecimal. Now at some point in the future I may go and add an extra section on how to convert manually between these, but we are not really concerned with that for right now. For the most part in programming, you will not do this manually. In all of my time programming, I've never truly been concerned with converting these things manually, and the thing is you kind of have to know about the different representations. You just need to know of the different types and that you can convert between them. And then an easy way of converting between them is using this calculator. You can just click on Start in Windows and then start typing calculator. So this is just the Windows calculator. It's set in standard mode right now. I'll just switch over to the programmer mode. Click here. You can switch by clicking. So I'll click on DEC for decimal. I'll type in 15, and that will then update the other ones as well. So I have hexadecimal, octal, and binary. And you'll see they are the same as what you'll get in this table. So that's another quick way of referencing that if you forget them and you don't remember the link to this or something like that, or you don't care to Google it, you can just do it quickly in this way. Similarly, if I go to here and I just do something like 10 in hexadecimal, that is A. Octal, we will be at 12. And you can check it right here. 10 in decimal, hexadecimal is A, and octal is 12. Of course, ignoring those zeros that come in front of those. Let's go back to decimal and do a bigger number. Now, as I start typing these out, you will see that the binary representation gets longer and longer. We need more and more characters, ones and zeros, to represent that number. But the hexadecimal will not quite be that long. So here with 50,000, for example, we have 5 characters to represent the decimal representation of 50,000. The hexadecimal is only 4 characters. Set that to 5 million and you can see the binary number here. This representation is very long. The octal representation is also quite a bit longer. The hexadecimal is a bit shorter. But okay, the important thing here is to realize that this value will have C's in it and B's and F's and so on. So if you see a memory address, don't be alarmed when you see like an F or a C or something, thinking it might be some random string or some garbage value or something like that, when in reality it could be an address. So we'll see what an address looks like next in Visual Studio. Alright, so I have this demo variable set to 12. Instead of building and running this, I'll just place a breakpoint down here and I'll run the Windows debugger. So if I bring up the console output, this is the value that we get. Now I'll go to debug, Windows, memory, and then select memory 1. You can have up to 4 memory windows open, but for right now I'll just select memory 1. I actually had 2 of those open before, so I'm just going to close the one to the right. Down here I have memory 1. Okay, so how can we search for where that demo variable is in memory? Well, we simply go and type out the address of operator and demo var, and that'll give us the address right here in hexadecimal representation, and to the right this will give us some of the contents in memory. So 0C here, that's hexadecimal for 12, and right here demo var contains that value 12. So to the left once again, that's the memory address, and right here is the contents. And then you also have this ASCII representation to the right here, and sometimes that will print out various strings to you. We won't use it in this demonstration, but this memory address you'll see 005FFAC0, and that is what we get in this address. I'll just stop that. Actually, before I end this lecture off, just a quick exercise for you. I'll run the debugger one more time. Go to that demo var, and you'll notice that the address will actually change each time. The address where the demo var is stored in memory will change. Okay, for this exercise, what I'd like you to try and do is to determine how many bits are in these characters. So of course we know at this point that these are hexadecimal characters. So C, for example, is hexadecimal. So using the table that I showed you previously, try and determine how many bits are in these characters. So in each one of these characters, and then also in a pair of characters like this. So where you have 0C, for example. Okay, I'll just bring the table back. Of course, decimal goes from 0 to 9, so that is 10 characters, and that is why decimal has a base of 10. The octal number system goes from 0 to 7, so that has 8 characters, which means that it has a base of 8. Binary has a base of 2, it has 2 characters, so 0 and 1. And then hexadecimal has a base of 16. So if you compare the decimal and the binary, you will see when we get to 15 in decimal, that is 1111 in binary. Now 4 bits is called a nibble. Previously I mentioned 1 byte is 8 bits. So if we go back to the hexadecimal column now, it goes from 0 to F. So all of the characters in hexadecimal can be represented with 4 bits. So in other words, with 1 nibble. If that is F, you can convert it to binary, and that will then give you 1111. Okay, so if we come back in Visual Studio, we have 0C. So one pair of characters like this is 1 byte, and then one character, so either the 0 or the C here, will be 1 nibble or 4 bits. Okay, so just trying to make sense of that. This is not super important, just a little bonus section and bonus exercise for you, just to once again try and get you more familiar with the number systems. Now in the future I may go and do an extra section or chapter on these number systems and how to convert manually. But for right now, this is about all you need to know about these number systems. Just try and understand the difference between them. So decimal, hexadecimal, we probably won't use octal all that much. And then binary is also another important one, because again, that is what the computer understands, right? Okay, so in this video, we've seen how to return the address of some variable using the address of operator. And so at this point, this may not be that useful. But in upcoming videos, we're going to see how we can store that into something called a pointer, and then how we can work with that.